The second of our properties that we look for when we have parallel lines, this is now still with geometry of straight lines, we have alternate angles. So alternate, think of alternating. So if you were in school or university or whatever, I doubt university, but anyway, if you were in school or whatever, working, whatnot, or maybe your parents, if not you, then during COVID, a lot of schools and a lot of jobs had alternating when you went into school and when you stayed home. So you would maybe go to school on Monday, then a different group would go to school on Tuesday, then you would go again on Wednesday, and a different group of the school would go on Thursday. So you alternated between going to school or not, but they also alternated between which learners went in. So we had F, right, which was corresponding angles. Now we're gonna jump to alternating. The reason it's in this order, but we're not following it, is this is fun, but co-interior works a little bit different. So alternating angles is if you can find an N or a Z shape on your parallel lines, with the two lines of the parallels being the main two lines of the Z or the N, depending on which orientation you are looking at. Then the two angles that are both on the inside of the parallel lines but on different sides, they're alternating. Okay, they're both on the inside of the parallel lines but on different sides. They're alternating around that transversal. Now those alternate angles will also be equal to one another. Okay, and you can go think about it in the sense of, if we have an F that is maybe like so, then this angle and this angle will be equal to one another because they're corresponding. But we've already done vertically opposite angles, and you'll see this line and this line on opposite sides of it, vertically opposite, is those two angles. Something I also often tell my kids is the alternating angles make me think of like underneath your knees, like if you bend your knee. And then one of my learners recently said, yeah, it's like the one angle is underneath your knee and the other one is above your foot, because that's also alternating. But anyway, oh yes, just like we said with corresponding also, we always call this angle and this angle alternating, okay, because they're on alternate sides, both from the inside there of that transversal with two lines, but they're only equal if you have the parallel lines. So the Z or the N can look various different ways, as long as it's on the inside, in between the two parallel lines, but on opposite sides of the transversal. So if you are given the parallel lines, then you can say the alternate angles are equal with your reason alternate angles and the parallel lines. Again, the parallel lines have to be there, please. Okay, otherwise your whole reason is wrong. Alternate angles on its own is not enough, because not all alternate angles are equal. It's the alternate with the parallel together that makes them equal to one another. Okay, and then we also have the converse, just like we had with corresponding. If they ask you to prove or to show parallel lines, if you can prove that the alternating angles are equal to one another, that will mean that the lines are parallel. And then because you proved parallel, you did not have it, but you did have that the alternate angles are equal. The reason is alternate angles are equal. This is what you have. This is what you have. So the part after the alternating angles, that's the portion that you have, that you were given, or that you just calculated. Okay, not your conclusion, please. So we're going to look at an example where we use the property because we were given parallel lines. That's now by A. And then by B, we are going to look at how we're going to prove that the lines are parallel. Okay, so both iterations of this theorem. Just like earlier, we are going to take it one transversal at a time. So here, by the first transversal. Okay, you see there's information on this side, and there's an information on this side. So that means x and 50 degrees are equal to one another because they're alternating angles, and you add the parallel lines. The parallel lines were given, and it's only because the lines are parallel that is why we can say that the angles are equal. Then our next transversal here by GH. Okay, the information is on this side and on this side, so y and 120 are equal to one another. And you have exactly the same reason. And then our last transversal here, there's a bit of information on this side and a bit of information on that side. Okay, you cannot say anything about 110 and y. They're not adjacent to the same transversal, so yeah, just keep that in mind. So z and 110 are equal, and again, exactly the same reason, and yes, you have to write it again. Now, in the previous video, we also looked at proving parallel, and when we were doing this, we had steps. We had to identify if you're going to use F, U, or N. We're going to use corresponding angles, alternate angles, or co-interior angles. And then you basically say that's your two main angles. You need to prove that they're equal to one another. That was step one. So now here, if we want to go use step one, we will identify there that this angle and this one should be equal if the lines are parallel. So we must show that they are equal. Then, that's our first step. Then our second step is now we use our third angle, the one we have not used yet, the one that is not in the FU or N. And we need to use that along with one of those that are in FU or N, either with straight angles on a straight line or vertically opposite angles, to find X's answer. So we go identify, this is our other angle, and we see, okay, here's a straight line, so these two together must give us 180. So it's 5x plus 70, and the other angle is 2x plus 5. And when we plus them, we get 180 because they are angles on a straight line. And then we go solve for x. So we add our like terms together. There's 5x and 2x, so together there are 7 of the x's. Plus 70 and 5 gives you 75. And then we can go identify. Happening to x on this side of the equation is a times 7 and then a plus 75. So we are working backwards. We need to first go subtract the 75, and then we have to do the opposite of multiply, which is divide by 7. And then we get x is equal to 15 degrees. And if we go look back at the steps again, we have already now solved for x. So our next step is going to be substitute back into angle 1 and 2, the ones that are being used that we need to prove equal to one another. So in this case, it will be E1 and F1. E1 is 2x plus 5, and F1 is 3x minus 10. And we do our substitution of 15 degrees. So in both cases, we get 35. Again, just like earlier, or in the previous video, we now need to show that we found that they are equal to one another, and then we can say therefore they will be parallel, but instead of corresponding, you will say alternate angles are equal. So we are seeing now here that E1 and F1 are equal to one another. Great. Then, because our alternate angles are now equal, we showed all the calculation. We never assumed anything. They did tell us straight lines, so we never assumed anything. We did our like an algebra there, or like a substitution, and then we found that they are equal to one another. This now means that AB is parallel to CD, because remember these were alternate angles. We use the Z, so alternate angles. And do we say now the parallel lines? Are we saying parallel lines here and here? The correct answer is no. Okay, so it's because the alternate angles are equal. And that's all for now. In the next video, we're going to look at co-interior angles, and then at some later stage, we will look at the more complicated questions that they can ask you not necessarily with proving. This is around about how difficult the proving the showing gets in grade 8, but the more complicated questions they can ask you with using your parallel lines.